Hello everyone. Today we will see what is HTTP and how HTTP communication works. HTTP is a secure HTTP protocol. It's protect against eavesdropping and man-in-the-middle attack, like man-in-the-middle in the sense like proxy and intermediate servers. HTTP is mostly used in web with secure transaction involved, like if you are doing any communication with username or password, and if you are doing any sensitive information, we'll go for HTTPS. So HTTP ensures the communication channel is encrypted and the communication channel is data is not tampered in the intermediates. Also, we can check that web server authenticity. So the server is the client, what the client is requesting, the server is authentic, or is there any snooping servers involved? So that authenticity we can validate with SSL. So the CA is a certificate authority. So the main purpose of certificate authority is to generate, it used to validate the certificate signing request and provide a digital certificate for the clients, for the servers. The CSR request obtains a public key and other information that includes domain name, organization, and email address, etc. And the private key should be reside. The server should keep the private key with it, and it shouldn't share the private key. Only the public key is shared in the CSR request. The CSR validate the CA validate the CSR request and sends a digital certificate. The digital certificate should be deployed in the web server for enabling the SSL site. So digital certificate provides authentication, encryption, and integrity. So here authentication in the sense the communication that a client can validate the certificate with the local trust store to ensure that what the certificate server certificate is valid or it's authentic, and whether it's valid in the sense the certificate is from validated tested by the certificate authority. Also that whether the certificate is expired or non-expired, all those things they can check. Also it ensures that encryption in the communication, so the communication channel is encrypted, data is transferred in that encrypted way, and it also ensures the integrity of the communication in the sense if anybody, it ensures that communication channel is protected and it's not tampered by any third party in the transit. So we can see the client in the client machine, we can see the local certificate store. So each client machine will have its certificate store. So that is automatically done by the OS at the time of provisioning. OS will ensure these root certificates are deployed. And if you want to see that in Windows, we can see open the Microsoft Management Console, and we can see that if we add a certificate snap in, and we can see the what are the certificates, root certificates, trusted certificates, and root certificates which are deployed in that machine. So this is a TCP. Now we'll see the TCP communication flow, how the TCP communication happens. So TCP, HTTPS uses asymmetric encryption for key exchange and symmetric encryption for data communication. So here the first one is first time is we need to do the TCP handshaking. So that is happens through TCP sync, and a server will send the TCP sync acknowledgement, and the client will send that TCP acknowledgement. So here the TCP first step is the TCP handshake. So once a TCP handshake happens, then the certificate check process will start. So here the client will say the client hello with the available the client will send the client hello with available in the client what are the available cyber shoots and the SSL version it's supported, and the client will check that cyber shoot, and it checks what are the approved cyber shoot server supports as well as the SSL version, and it responds with that approved SSL cyber shoot and SSL version. Then the server can then the server send that SSL certificate as well as the server's public key to the client. Then the server, now the client can validate the SSL certificate with the local trust stored if it can proceed for the further only when that SSL or the server sends SSL certificate is valid and it authentic, then it can go consider the server is a valid one and it can go forward. Otherwise, it gives a warning in the browser. So now here the key exchange. So in the key exchange, it uses asymmetric encryption. Now the client generates a random session key and encrypt with the server's public key and sends that encrypted session key to the server. And the server now the server decrypt with the server's private key and obtain the session key. Hereafter the data transfer now happens. Now the client and server can communicate with the symmetric encryption with the shared session key, because now the client and server only knows that shared session key. Now the data transfer will happen with that shared session key. Since the session key was only decrypted with the server private key, no one in the middle can intercept that communication. So only that server and client can able to aware about the data, transmitted data. So everything the channel will be now encrypted. So this is how the SSL HTTPS ensure that communication channel is protected, and it ensures the security of that communication. So here we have the question. So why we need to use symmetric encryption for data transfer alone instead of asymmetric encryption? So because since symmetric encryption was faster and cyber text and plain text are almost same in size, it won't the network communication won't be blocked. So it won't bug in the sense it says size of the data will be same. But in the asymmetric encryption, that it generated it might increase the size of the data cipher text might increase, so that it might latency, the network latency might be increased. And the symmetric encryption is preferred for data communication because of it's faster in nature, and size of the ciphertext is not becoming bulkier. So it is best to use symmetric encryption for data communication, and we use asymmetric encryption for key exchange, because here the main problem is we need to how we need to generate the session key. Some of the session key need to be transferred for this communication to happen. So that's why we use asymmetric encryption for session key transfer the initial time, and we use symmetric encryption for data transfers.